So once we understand the different types of central tendency, which is where most of our data are located, and once we understand the variation, so how spread apart are our data, then the next topic that we're going to go through is outliers. In statistics, outlier is an observation point that is distanced from the other observations. So basically, outliers are observation points that are really far away from where most of the data are located. So that's the first type of characteristics. And the second thing that you need to know about outlier is that outlier is usually considered experimental error, and therefore we exclude them from the dataset. And how we determine whether something is outlier or not is we look at the z-scores. If the calculated z-score is less than -3 or greater than +3, then they're considered outlier. So that's the criteria that we use to determine whether they're outlier or not. So that's the -3 and greater than +3 for the z-score. And how we calculate z-score is we use this formula here. Z-score equals to x minus x bar, which is your mean. So it's x minus the mean divided by sample standard deviations. So that's the formula that we use to calculate the z-score. So the idea is that once we calculate the z-score, if they are less than -3 or greater than 3, then they're considered outlier, and therefore we exclude them from the dataset. The next definition that you need to know is the shape of the distributions. We have skewedness and kurtosis. Skewedness measures the extent to which the data values are not symmetric. So we have three scenarios. It could be left skewed, symmetric, or right skewed. Symmetric means that our dataset are pretty much the same for both left side and the right side. And usually when the dataset is symmetric, our mean will equal to the median, and our statistic skewedness will be 0. The second scenario that we have is left skewed. In the left skewed scenario, usually our mean is less than our median. And how you can remember whether this is left skewed or right skewed is you look at the tail of your dataset. So for left skewed distribution, you can see from the diagram here that most of our data are located in the right side. So therefore we have our left tail. So we have left tail, and the left tail means that we have left skewed. So when we're determining whether the data is left skewed or right skewed, we look at the tail of our dataset. We don't look at the body. So when we have a left tail, that means we have left skewed. Same idea for right skewed. When we look at the distributions, what we can see is that we have right tail. The tail is where you have the least data. So when we have right tail, so what that means is we have right skewed. So the tail will tell you whether this is left skewed or right skewed. And that's skewedness. Next definition is kurtosis. Kurtosis measures the peakness of the curve of the distribution. So how sharply the curve rises approaching the center of the distributions. And the higher the kurtosis, the sharper the peak. The smaller the kurtosis, the flatter your bell curve. So these are definitions that you need to know. The next definition that you need to know is box plot. Box plot shows you a graphical display of the data based on the 5-number summaries. And these are the 5 numbers that you're looking at. The smallest number, Q1, median, Q3, and largest number. So smallest number is your minimum. Median is your median, that's your middle number. And largest number is your maximum value. And then Q1 represent your first quartile. Q3 represent your third quartile. And how you can understand quartile is that you have to understand the concept of quarter. So quarter is 25 cents. So one quartile is 25%. So quarter, 25 cents. Quartile is 25%. And that's what one quartile represents. One quartile represents 25%. So if you have the first quartile, that means you have the first 25%. And if you're at the third quartile means that you have 3 quarters. So 3 quarters means you have 75%. So 3 times 25 gives you the 75%. So that's the third quartile. So if you look at these 5 numbers, that's what these 5 numbers represent. The minimum, that means you have 0% of your data. Q1, that means you have 25% of your data. Median means that you have 50% of your data. Q3 represent you have 75% of your data. And the maximum means that you have the 100% of your data. And that's what the 5-number summary tells you. It breaks down your data set by 25% group. And from a graphical perspective, this is what it looks like. We have the smallest number, and the largest number on the outside. And then in the middle, we have a box, and that box represents your Q1, median, and Q3. So on the outside of the box, we have the Q1 and Q3. And then inside the box, we have a line. That line represents your median. And then the gap between each of these numbers represent 25% of your data set. So the gap between the smallest number and Q1 is the first 25%. The gap between Q1 and median is the next 25%. And the gap between median to Q3 is the next 25%. And the gap between Q3 to largest number is the next 25%. So total 100% of the data set here. And the gap between Q1 and Q3, that distance here between Q1 and Q3 is what we call the IQR. So IQR equals Q3 minus Q1. And the IQR measures the spread in the middle 50% of the data set, because we have 50% of the data set between Q3 and Q1. So the IQR shows you where the middle 50% of your data are located. So once we know the definition for IQR, Q3, and Q1, then we can now calculate these three numbers. So to calculate Q1, the first quartile, the formula that we're going to use is equal quartile. And you'll see that Excel has different formulas here. We're going to choose the second one, the quartile.exc. So that's the one that we're going to choose. And then we're going to open bracket. And then we're going to highlight the data from B12 to B61. And then comma. And then it will ask you for which quartile you're in. So the quartile that we're in is we're calculating the first quartile. So that's why we put the 1 there. And then we close the bracket. And then we press enter. And then you're going to get 15 days. So again, equal quartile.exc, and then you're going to highlight the data from B12 to B61, and then comma, first quartile. So we put a 1 there, and you're going to get 15 days. So next we're going to calculate Q3, so your third quartile, and the formula that we're going to use is equal QUAR TIL.exe. So this is the formula that we're going to use, quartile.exe, and then we open bracket, and then we highlight the data from B12 to B61, and then we comma, and then it asks you for the quartile. Quartile, we're looking for the Q3, so third quartile. So we put a 3 there, and then we press enter, and then you're going to get the third quartile, which is 55.75 days. So once we have Q1 and Q3, then we can calculate the IQR. So IQR is just your Q3 minus your Q1. So 55.75 minus your 15, and that's your IQR. IQR is 40.75. And that's your answer there. So the new formula that you need to know for Q3 and Q1 is equal quartile.exe, and then highlight the data, comma, for the quartile. So if you're looking for Q3, then you put a 3 there. Same idea if you're looking for the first quartile, equal quartile.exe, highlight the data, and then comma, and then you put a 1 there because we're looking for the first quartile. And then sometimes your question will ask you to calculate the ranking, the percent ranking, and then the percentile. So you can use these formulas to calculate that. So part C of our example 1, if we want to construct a box plot summary, this is what it looks like here. We have the 5 numbers. The smallest number is 1. The biggest number is 164. And then inside we have the box here. On the left side of the box, that's your Q1. Our Q1 is 15 days. On the right side of the box, we have your Q3, which is the 55.75. In the middle of the box, there's a line. That line is your median, and that median is your 27. And this is what it looks like graphically for a box plot summary for our example 1. And is this dataset skewed? If so, how? So this dataset is right skewed, and how we know this is right skewed is because when we look at the IQR, we know that IQR represents the 50% of our data, the middle 50% of our data. So therefore, when we look at the box plot summary here, we know that most of our data is on the left side. That's where the body is. The body represents the middle 50% of the data. We have the middle 50% of our data on the left side. So since we have 50% of the data on the left side, so that means we have right tail. So right tail represents we have right skewed. And that's the answer for example 1, part C.